Morning. Welcome to the webinar today. I am Sarah Swango, Vice President of Corporate and Foundation Relations here at NIBS. And again, welcome to the Circular Economy, a Pathway to Net Zero, hosted today by the BSI Group. Each year, the National Institute of Building Sciences hosts the Building Innovation Conference, reaching building professionals across the country. In May, we hosted a successful in-person conference here in Washington, D.C. We are continuing our Building Innovation webinar series to allow built environment professionals the opportunity to virtually learn by providing a platform for subject matter experts to speak on a variety of topics. This session will focus on the concept of the circular economy. The built environment consumes 40% of all resources globally, generally following the take, make, waste linear economy. By contrast, the circular economy in the built environment is a systems-based industrial framework designed to tackle global sustainability challenges such as climate change, waste, and biodiversity loss. In a circular economy, products and materials are reused, repaired, recycled, or repurposed to create new products, contributing to a more sustainable and resource-efficient economy. I'm excited to learn more about this from our session speakers, August Nazareth, who is the Global Director of Built Environment of the Americas at BSI Group, and Rabia Sharaf, who is an architect and researcher at Lancaster University. Before we get started, I do have a few quick housekeeping items for everyone. Number one, participants will be able to type questions by selecting the Q&A button in your webinar or on the Zoom platform. We will select the questions from that list after the presentation, and our presenters will also be monitoring and may be able to answer as we go along. Please note that we may not be able to get all the questions answered, but we will try our best. This session will be recorded and live streamed to our Facebook page. The recording and written summary, including any prominent websites, will be available on our website next week. And lastly, NIBS will be contacting all attendees with information regarding continuing education credits and certificates of attendance. And please reach out to us if you have questions or would like to be in contact with our presenters today. So without further ado, I will hand it over to August. So take it away.
Thank you, Sarah, for your warm welcome at BSI at NIBS. Hello, everyone. We're really excited to join you in our discussion on the circular economy and the net zero journey. I'm really delighted to be here alongside my co-speaker Rabia Sharaf. We're really excited to share our insights and enthusiasm for the circular economy and how it impacts the architectural, engineering, and construction operations space with sustainability. Regardless of whether your perspective is design, construction, facilities management, or digital perspectives, our goal is to inspire you on the sheer possibilities. Briefly, I've spent the last decade working in BIM and Autodesk partner consultancies, both in the US and the UK. In 2016, I discovered the circular economy and pursued an MBA in enterprise innovation and circular economy at Bradford University. Currently, in my role at BSI, I work with the built environment sector across the Americas, connecting our extensive resources, subject matter experts, domain teams, and knowledge solutions, and connect them with communities, clients, and partners that all share a common goal. Today, those goals are climate change, sustainability, and resilience. I'll now turn it over to Rabia to introduce herself.
Thank you, August, and welcome everyone to this exciting webinar. Just a few words about myself. I worked as an architect for 15 years, jumping from residential housing and healthcare buildings. I actually designed a dozen of very complex buildings in France. But I have to admit that I never gave much thought to the end of life of my beautiful design. So to improve my design and update my skills, I went back to school to learn new ways of working. And I discovered the power of the new technologies and how we can link the design phase with the asset end of life. I was so passionate about the subject that I did a PhD on it, and I moved my career to academia. I am currently a researcher at Lancaster University. The main areas of my research are digitalization, material passports, and the transition to a circular economy for the construction sector. With a strong track record of scientific publication and book editing on this topic, I have collaborated with international institutions and used my voice as a speaker to advocate for transitioning to a circular economy. I am also involved in the standardization activities at the European level. As a practitioner myself, I am deeply committed to making my research practical and valuable for practitioners. Now, without further ado, let's begin the journey for this webinar. The floor is yours, Auguste.
Thanks, Rabia. So a little bit of an introduction to who BSI is. BSI stands for British Standards Institute and is one of the first standard bodies created to build better practices across industry, beginning with steel for tram tracks over 100 years ago. We're responsible for many of the standards you use today in the built environment and other sectors, and have industry experts in our advisory and consulting divisions with a strong footprint in the US, and we are also headquartered in Virginia. Our clients and partners come from almost every country in the world and range from big brands that you recognize every day to small local businesses that need our assistance in running their businesses. In an industry that consumes almost 40% of all resources, as Sarah mentioned, BSI's role is to support industry stakeholders across the building life cycle with forward-looking innovative ideas for digitally transformed, sustainable built environment. One of these is the circular economy. We have a bit of an action-packed webinar today, so I'm not going to read the slide, but briefly, we focus on some key themes in the US and globally. We empower our clients to manage and protect not just their teams with best practices, but also their physical and digital assets with a 360-degree outlook. Specifically, they include sustainable infrastructure, BIM and digital twins, health and safety, and quality management. For our agenda, we'll look at key influences and contributors to the circular economy. We're going to address some key factors on CE and the principles for materials and how crucial design considerations become as the materials move through their product life cycle. Next, we'll take a look at that design inspiration from nature in a closed loop example. We'll also touch on how many new US legislative acts and funding may provide a new impetus to combine net zero, new technologies, and circularity for greater results. We'll highlight very briefly some circular economy business models and enablers. And finally, we'll bring the circular economy, nature's inspiration, and the built environment together in 6 case studies. These studies will range from designing in circularity right at the onset, a US brownfield project, ecological restoration. Rabia's 4 case studies highlight interesting projects on existing materials usage, material passports, and digital and low-tech methods. And lastly, we hope to have some time for some questions. So who are the influences of the circular economies, and how do we arrive at some of these schools of thought? Some of the main ones, shaping thoughts came from the Cradle to Cradle book and Remaking the Way We Make Things by German chemist Michael Braungart and American architect Bill McDonough. This was published in 2002 and introduced the concept that all materials should have a planned future, becoming an input for another process in a continuous sustainable cycle. Walter Staub, an architect and economist, champions for the concept of product service systems. Here, the focus is providing services, not product sales. For example, cooling as a service charges the building operator on a pay-as-you-use basis. In this example, the manufacturer retains ownership of the system, and it enables the reintroduction of older components back into their own supply chain. They never lose custody of their product, or in fact, their brand or their customers. It's a really powerful concept, which is really not used enough today. Janine Benyus, her innovation inspired by nature is a book that promotes the imitation of nature's design to solve human problems. And we'll look at that from a forest perspective that could be mimicked in a smart city perspective. And finally, let's talk about Ellen MacArthur Foundation. Founded in 2010 by Ellen MacArthur in England, the EMF has significantly accelerated the transition to a circular economy. The interesting aspect probably for me is the astonishing momentum achieved by Ellen MacArthur. Along with her team, not only was it a concept that she really believed in, but they achieved recognition like wildfire through activities, events, research, really smart grassroots marketing. This momentum led to 100 large organizations like Philips, Renault, Hewlett-Packard as the CE 100. And today, as a result, my HP printer actually has a cartridge take-back system. This is from these activities more than almost, I don't know, I would say 10 years ago. In the rest of our discussion, these concepts shape new thinking for today's challenges and opportunities. But what exactly is the circular economy? It's an industrial system that is driven by design and based on three principles: eliminate waste, pollution by design, circulate products and materials at their highest value, and regenerate nature and natural systems. At its heart, it's an industrial system that is regenerative and replaces old concepts of end of life by using superior design of materials, of products, systems, and creates the business models to make it possible. More importantly, as an industrial system, it has monetary value. In a 2022 report called The Evolution Towards Circular Economy, Goldman Sachs estimates that the CE could add $4.5 trillion in additional economic output by 2030 globally, and another 25 trillion by 2050. With numbers like these, maybe it's not just a maybe for the circular economy or a nice to have. It becomes a really significant business proposition. So why now? What's the impetus for the circular economy? It's been included in the latest U.S. acts, the infrastructure, the Inflation Reduction Act, the CHIPS and Science Act, and the bipartisan infrastructure law worth collectively over $1 trillion in key investments and tax incentives. These tie in with the circular economy for recirculating materials and reducing pressures on the supply chain for EV batteries and clean energy technologies. From a federal Buy Clean perspective, cleaner production and recycling is encouraged for materials like steel and concrete. And of course, extending the life cycles of materials lowers your greenhouse gas emissions. I would say, though, the main takeaway of all of this is that circularity has been written into these acts. So it legitimizes CE, and the funding is available for innovation that will be part of a wider sector requirements in the supply chain and will eventually fan out to the built environment. So we've established the why of the circular economy. And one easy way to visualize it is the butterfly diagram, which governs how materials are separated by type and their treatment throughout their life cycle. Biological cycles, and the smaller the tighter loops here, as you can see on the bottom left, represent innovative byproducts, such as textiles from orange peel, animal feed from mushrooms, before moving to the wider loops. In a technical cycle, you'll find on the right, you'll find smartphones, laptops, sheetrock, steel, glass, which benefit from modularity, disassembly, adaptability, design. And again, in both cycles, the smaller the loop, the more the material's original value is extended, including embodied carbon. So if it's important to have these materials and extend their lifestyles, it leads us to an important question. How do manufacturers reclaim materials from years after they've been installed in the built environment? Armstrong, Shaw, and Tarkett all have take-back systems for reusing materials. Old ceiling tiles become new ceiling tiles, and old carpets become inputs for new carpets. They've created ways of separating these materials and breaking them down and then reinserting them into their supply chain. The materials are diverted from landfills, reuse new raw materials, and ties in with the goals of the legislative acts. Next, we look at the perfect ecosystem, illustrating a connected, closed-loop system approach mentioned by Janine Beneus. CE influences call for designing our homes, communities, and cities in a similar fashion to a forest. It's a perfectly designed ecosystem for carbon sinks, symbiosis between vegetation, water systems, animals, fungi, bacteria, and underground mycorrhizal networks for soil preservation and regeneration. In this system, every output becomes an input for the next process, the next animal, the next insect, and a circular economy seeks to mimic nature at its symbiotic level by design. Nature also creates perfect products, such as the humble banana. It's perfectly designed package for mobility, life stage information, ease of use. It doesn't really require any plastic or packaging around it. The entire product is usable by all consumer markets, as well as in business-to-business settings for nutraceuticals. And in some tropical countries, the entire tree is consumed, including the trunk, which is just another vegetable. I imagine it tastes like potatoes. In a landfill, bananas facilitate the decomposing of adjacent organics. So why does it matter how the forest, banana, or material segregation occurs? Why do we care? We care because design has long been used We care because design has long used nature as inspiration. However, somewhere along the line, there's a disconnection between design, nature, and how we design products for our world and use. All these items on the left are very likely recyclable according to the manufacturer, but hardly any are. They're not recycled and they're not reused. In the AECO sector, if you haven't heard this phrase before, think of our buildings as material banks, a collection of highly valuable materials and products like steel, concrete, woods, glass, pipe, etc. Some with designed and planned for reuse, but much of it will be discarded because there isn't a way for these materials to make their way back into the supply chain or even the secondary markets. These are products without a plan, without an identifier, or information on what to do with them. However, we think it's just a matter of time before things like QR codes, RFID, IoT sensors, etc. are used to tag, meta tag, and identify the manufacturer and life stage, and perhaps reverse logistics and take-back systems become visible through digital twins or similar technologies. And we're suggesting this will happen because of new laws, environmental regulations, and extended producer responsibility. So why do we have this situation? We call it the linear economy. The linear economy is also referred to as the take, make, waste economy, where goods always move in one direction, from raw extraction, manufacture, use to waste. As we know, sometimes that use is only a minute. It's really carbon intensive and is driving climate change and biodiversity loss. However, that's really the dichotomy. The Industrial Revolution brought many benefits. For the first time, goods were able to be mass produced. Raw materials and energy seem to be infinite, and industrialized countries have become societies of abundance with soaring populations, and many millions have been pulled out of poverty. The pros and cons of all of this. So countries have gotten out of third world status, have middle classes that can afford to live without disease and hunger. But all of this has a legacy footprint of process machinery, logistics, and communities that really rely on the linear economy. And that's why it's such a dichotomy. So the next slide, borrowed from Rabia, shows the comparison of both economies. If we can be mindful about our materials and how we design our buildings, we can influence suppliers. What we hope this presentation does is to spark innovation in design and new ideas that prevent this take, make, waste ethos that now exists. And now we know there is funding available, and the impetus for change will arrive with it new project requirements in the built environment. Further, we're seeing design software is getting more sophisticated in terms of built-in sustainability, measuring and simulating building performance before we build the actual buildings, and material choices, etc. So there are many opportunities to make differences in individual ways that fit into your organization. And you'll see that the intervention points in the case studies are also very different. And perhaps you're already on the journey to the circular economy or greater sustainability. This is a clear comparison of the linear economy and circularity in a construction context. And as you can see here, it just really depends on how each organization is created. Next, enablers and case studies will provide validation on how these concepts integrate effectively. Because the business models and enablers for circular economy has data as its backbone, some of these solutions will accelerate the circular economy regardless of what you call it. Because data is the result, and we need data to locate these materials, we need to know what they're made of, we need to know what their material passports are. So whether you're talking about prefabrication, off-site modular buildings, or you're talking about the creation of digital twins, all these things lead to a circular economy at some point. And now let's dive into case studies. I have two. The circle in Amsterdam is one of my favorite examples. ABN Bank AMRO's Circle encourages, which I encourage a review of their online story linked in the slide. ABN is a major player in the built environment finance, and their new headquarters in Amsterdam was seen as a key opportunity to demonstrate their credentials to customers, investors, and regulators. Not only that, but Amsterdam and the Netherlands have the circular economy almost as their culture. So they had to come up with a resounding demonstration of their commitment to circularity. And I think this building really does it very well. They reimagined what a bank looks like for this project. There's no marble or slick surfaces. It took a much longer time to get the project going because they couldn't find a supply chain and materials without ingredient mixing, which is crucial to the project. Interestingly, the building techniques include screws, clamps, but no glue or paint. Only bare materials were used to promote future disassembly and reuse. It's an example of how circularity can be designed in. The case study number 2 is the Ford Rouge Center in Dearborn, Michigan. I won't read the whole slide, but Bill McDonough and partners led the master planning and revitalization of this very huge, large historic site and facility. The ambitious 20-year plan pioneered strategies and technologies for brownfield redevelopment, sustainable industry, and environmental regeneration and restoration. I think these two pictures tell 1,000 words. It's also a new form of stormwater management infrastructure saved the company $35 million in capital costs over a conventional system. And at the heart of the new system lies a 10.5-acre living roof, the world's largest at the time. The roof attracted birds within 5 days, nesting and laying eggs, which is a high compliment indeed from nature. And now I welcome Rabia Sharif, who will detail 4 built environment examples of not just circular projects, but also projects that easily lead towards circularity.
Thank you, August, for shedding a light on such a fascinating topic. It was really inspiring. I will now take you, the audience, on a journey and present 4 case studies. So in a nutshell, and to sum up what August said, what is the problem of the construction sector? The construction sector is responsible for a massive amount of waste. In Europe, for example, the sector generates 35% of all waste and consumes more than 50% of all natural resources. But the harsh reality is that we have only one supplier, one planet with finite resources, and the demand is continuously increasing, whether we are talking about the housing needs or the standards of living. Next slide, please. So we are actually facing a sustainable growth dilemma. The question is, how can we continue to grow within the alarming equation of resource depletion, waste generation, and gas emission? In other words, how could we be part of the solution instead of part of the problem? To rebalance this equation and to be able to meet the growing demand, we need to do more with less. We have no other alternative. We must consider moving to a circular economy and using existing buildings as material banks and materials that are already there around us and under our feet. It was also said by August. We also need to question our needs, especially in terms of comfort and occupancy, and strive for sobriety instead of seeking efficiency at all cost. We must rethink how we produce, consume, and live, and be respectful with our environment. Now, let's see some case studies illustrating potential solutions. One key aspect of the circular economy is to change how we design our buildings to make them easy to disassemble and increase the reuse potential of their components. Here is an example of the first social housing project in Denmark. The main goal of this project was to demonstrate the possibility of designing houses with 90% of materials reusable without any loss of value. It was built according to the circularity principles and designed to be disassembled, which is a crucial aspect for the circular economy. In this project, several construction systems were used, like precast concrete elements, beams with mechanical joints, and modular building systems. A unique aspect of this project was involving stakeholders early in the design phase, like building contractors and demolition experts. They also made adjustments to construction business models, and they adopted modular construction techniques. They used recycled materials, implemented a leasing model for building components, such as the facades, the windows, and the flooring. Why the leasing model? Because it allows manufacturers to retain ownership of these components. They lease them to the building owner. At the end of the building life cycle, components can be returned, refurbished, or reused in new construction. Additionally, they developed a freely available guide for implementing the circular economy, including 15 circular economy principles. You can find the book online. So this was an example of new buildings, but to meet environmental goals, many studies highlighted the importance of refurbishing and reusing existing buildings. Why? 85% to 90% of today's buildings are expected to still be in use by 2050. So we must extend the service life of our buildings and consider them as material banks. So now let's talk about our next example, designed by the architectural practice ORMS, based in London. ORMS has a long history of working with existing buildings. They work across different sectors and always have the same approach. They retain, refurbish, and reuse as much as possible. They are committed to achieving net zero carbon and understand their impact because they calculate their annual carbon footprint and the carbon footprint of their project. In their building, the first thing they do is to assess the material on site to determine if they can be reused or not. Because they consider they consider waste as materials without identity, they developed the material passport to facilitate the reuse of buildings and their components. And more recently, with Lancaster University, they published a policy paper with recommendations on how to use material passports to accelerate the reuse of materials. You can freely access to this document online. So now let's delve into the 10 Spring Gardens project, which is a significant refurbishment initiative. ORMS has designed the project with sustainability at its core to retain over 90% of the existing structure and facade. At the beginning of the project, the client requested two key reports. The first one, building condition inspection, and the reuse viability assessment reports. Why these reports? It's because these reports confirm the potential for refurbishment and reuse of the building. They support the creation of the refurbishment framework. They inform the brief, and also they assist in identifying the value of existing materials. ORMs wanted to retain existing materials, but they also aim to source recovered materials to minimize the need for new ones. They identified several elements that could come from reclaimed sources, like brick, flooring, feature lighting, furniture, windows, and clay pavers. And to secure future reuse of these materials, they will provide an identity by using material passport for recovered and new materials. They also engaged with suppliers of new materials for future take-back schemes, as Auguste explained previously. It has not been easy so far, as the project team has faced many challenges, including trading the recovered materials. It was difficult because it was just the beginning of second-hand material platforms. The reuse of recovered materials, mainly due to technical requirements, regulations, and aesthetic specifications. They also faced challenges for storage and waste. The construction program itself was a challenge because products need to be agreed upon about a year before installation. Now let's move from London to France and this office building, L'Orangerie, located in Lyon. The approach was to use excavated earth as a construction material for the facade. The aim of this project was to demonstrate that it is possible to build a contemporary building with rammed earth, which is a traditional and ancestral construction process. They used uncommon construction methods. The facade is made with structural blocks of rammed earth that have been prefabricated on site and stored several months before the start of the project. They used a stone-based solution to tackle the flood risk, as you can see in the picture. To meet the seismic regulations, the timber floors connect the fore facade and the stairwell. Rammed earth is made only with earth and water, nothing else. And this is the reason why this material is completely aligned with the circular economy principles, even if this building is usually not presented as circular and is not certified as well. But this project was not easy to do as well, because to move from inconceivable to achievable and then build this project, the construction team has to overcome different challenges. First, the use of non-standardized materials. This is an unusual construction system, and there is a lack of appropriate regulations. The excavated earth from the construction site did not have enough clay, and it was not possible to do rammed earth with it, and it was polluted. So the project team decided to take the material from a nearby construction site, which was waste intended for landfill. The on-site prefabrication of the rammed earth blocks was a challenge because it needs storage spaces and protection against rain. Another challenge was the need to manage the project differently. The role and responsibilities of the actors were different. The mason, for example, became a key player and was involved in the design team. The lack of confidence in rammed earth techniques was also a big challenge. There was a long discussion and arguments about whether to stabilize the material or not. And it was an important decision, actually, because of the environmental impact. Indeed, cement stabilized earth blocks have a higher embodied energy because of the quantity of cement that they need to be incorporated. For this reason, no cement was used except for the foundation. And again, No plasterboard, no paint were used. And maybe the most important challenge for this project was the need to adapt the design to the material and not the other way around. Our last case study was designed by a team that doesn't call their approach circular, but consider it as a common sense and respect. The project is the Beaucastel winery, famous for producing some of the finest wines in France. And for the most recent renovation, this building was created in the 17th century, and the domain was expanded many times. But for the most recent renovation, the owners held an architectural competition that attracted 1,200 applications from 32 countries, just to highlight the global interest and prestige of this project. To realize this, the owner's vision, 2 studios were chosen, Studio Mumbai from India and Studio Méditerranée from France. The philosophy and approach of this project revolve around the idea of building together. The project team, inspired by Tim Ingles' making, considers materials as active collaborators and not just resources. This means fostering a collaborative and respectful understanding of materials. That's the other.
Sorry about that.
As architects, they worked harmoniously with the context and ensured that the design was not imposed, but rather seamlessly integrated into the environment. This approach aligned with what Auguste said about mimicking nature, where there is no waste. Next slide, please. So now let's explain the approach and construction process for the Beaucastel project. First, the project team assessed and understood the site and existing buildings. They used several types of diagnostics to help them to make informed decisions for preservation, renovation, and adaptive reuse. They also, usually consider having 2 types of materials for all their projects, actually. The natural site material, the ones we have under our feet, they looked at how they can use this material for the construction. For example, earth with clay, pebbles, gravels. And the second type of materials is the human-introduced site materials. The analysis of these materials revealed 3 main periods. For the first period, because it was well constructed and the materials were easy to reuse, it was stone, pebbles, wood. They kept everything nearly and repaired the building. For the second period, they were able to deconstruct only 40% of the structure and recycle metals and concrete. Downcycle the concrete, actually. Unfortunately, and interestingly, the more recent period has proven less easy for reuse for 2 main reasons. The first one, buildings were mainly made of composite materials that are difficult to separate and reuse. And the second reason is that they often contain environmentally harmful plastics. So, although Beaucastel project is not certified as circular, it was designed and constructed with a closed-loop approach because it reused 80% of the existing materials, including the soils excavated to bury the main building. They used several innovative techniques. On the right, they used site-rammed concrete. They made it with excavated soil and cement. On the bottom left picture, you can see the rammed earth wall. When the soil has clay, cement is not necessary to manufacture the rammed earth, as I said previously. So they just use earth and water. And the picture in the center shows the pneumatic rammer that was used for both techniques. Even old timber beams have been recovered and upcycled to make furniture. From my point of view, this project is remarkable and demonstrates that it is possible to keep existing materials in a closed loop and limit the extraction of new resources. Every project should be designed this way to ensure resilience. So, based on this case study, several challenges have been identified at different scales. For the construction sector, the main challenge is the lack of digitalization. For the deconstruction, it requires specific skills. It takes time and costs more compared to demolition. At the building scale, the main issue is that existing buildings were not designed for deconstruction or adaptation, but in the linear economy. Consequently, materials often get damaged during deconstruction and cannot be reused. At the scale of material and component, there is a lack of information, and the use of material passport can really help for that. Another challenge is that the second-hand market is not well structured, and the supply and demand are not well balanced either. Here are some recommendations and insights to raise awareness. We need to support the industry by providing guidance, standards, and incentives. We also need to develop assessment methods to prevent greenwashing. Digitalization should be applied meaningfully to avoid rebound effects. We need to keep in mind the brand layers theory, which I believe is a crucial aspect of the circular economy. We must change the way we think and design our buildings and components. We need also to have the long-term thinking and be aware of the long-term consequences of our actions. And we should remember that sometimes a low-tech approach could be the best solution. Well, that's all I have to say today. If you are interested, you can go and read the chapters where this project are explained in a book that was recently published. We put the reference in the list, and that's it. Thank you for your attention, and I will give the floor to August.
Thank you, Rabia. I love those case studies. They're not just interesting and make the most of materials, but they really are gorgeous. Anyway, and they look at materials and design with the backbone of innovation, where is achievable without the same fanfare of the next iPhone. You know, everybody gets excited about that, but here we are creating, in the construction industry, creating really cool projects. So thank you everyone for your attention, and we hope we've sparked your curiosity with our case studies and information. Just to recap, we've discussed what circularity is, contrasted it with the linear economy, and then brought it around to how it works in the built environment. From a practical perspective, you've seen how the case studies have show how redesigning projects, even without a CE label, also works towards sustainability and, as Rabia says, common sense. And lastly, we've highlighted the immense opportunity that exists today. There's funding that exists, there's interest in the circular economy, and we can tackle one of the greatest challenges of our time and for climate change and resilience. So thank you for attending, and I will pass this on back to Sarah.
Thank you, August, and thank you, Rabia, for your great presentation today. That was wonderful. Because we do have 10 more minutes to go in this webinar, we want to make sure everyone does still get their continuing education credits for participating. I think it might be a good idea to answer some questions if you are up for it, and I can read them to you. I don't know if you answered. I don't think you might have had a chance to answer these questions yet, but I am going to throw some out to you if you don't mind. Let's see. So I guess someone asked, can you describe more about regenerating nature and what does that mean?
I think that means your systems that, so for instance, if you were to use many of our vegetables and produce, for instance, a lot of them are wasted. And in many cases, those can all be repurposed, the bushes, the actual trees and plantations can go back into the soil instead of using things like fertilizers.
That's great. Thank you for clarifying that. Okay, and then another question is, how critical is the adoption of digital product passports to the enablement of circular economies for construction?
I'll
Let me
take
know
that.
if I need to repeat that.
Yeah, I'll take that one. So in one of our slides, we indicated how that data is at the backbone of the circular economy. So we've got materials, and as you can see, in some buildings, you've just got as material banks, you've got so many products in there. So if we have material passports and we also have some meta tagging and we have the metadata, which are maybe continued on in, so today this hot topic is digital twins. Now, all of a sudden you have, once you set up the data, you have the means to call up that information. Maybe you're using AI to quickly bring information and surfacing that information so that, when say your air handling unit is not working on the 9th floor, it's really easy to call it up on your digital twin. You pull up the data, you find out who the manufacturer is, you find out its life stage, is it at the beginning of its life, the middle, or the end? And now you have that information. You know exactly who the manufacturer is without rummaging through, that is how they did it in the old days, through vendor books and looking through loads and loads of information. I hope that answers the question.
That was great. And I guess we'll maybe ask a couple more questions. Someone asked that they're there or stated that they're very interested in the cost of magnitude related to circular economy. And are there guidelines or check and balances to the process?
The cost of the circular economy is it's really difficult to figure out what the cost of it is. However, we do know how much it's worth according to Goldman Sachs. And that number really surprised me. Up until about 2020, the circular economy was going to be worth 1.8 trillion. And now it's really jumped to 4.5. And there is a lot of research to back that up. But the question that it's really subjective, because it really depends on all the systems. It depends, is it in a global context? Is it in a national context? It's hard to quantify that.
And then let's do one more question. How does the insurance company treat buildings that are built using the circular economy in mind?
I can take this one.
Oh, that's good. That's a very interesting question.
Yeah, and I think this is a big challenge because it depends on the country that we are talking about. But I can give the example for France, for example, and they really need evidence of the performance and the system that we are using. For example, in the case study in Lyon, they have to work with researchers. They did a lot of tests to make sure that to provide evidence for the insurance. And finally, after many discussion, they accepted to take the risk. But I think we really need some regulation about it and to help the process, because we have the same problem when we want to use recovered materials.
Right.
So there is a very big need in this area.
And then let's there's one quick question that I think we can answer is where can I find the links to the case studies? And I think we can post these links on our events page, if that's okay with you, Rabia and August.
Yeah,
Okay.
perfect. I
Okay,
think,
great.
yeah, these case studies, most of them, the first one designed for disassembly, it was published. It's an available book. It's free. You can find it online. We will provide the link. And the 3 other case studies, there are chapters about them in a book that we are going to provide the link as well.
Great. Okay. And I guess let's just ask one more. There are so many great questions coming in, and I want to try to get to them, and then we'll let everyone go. But who can advise federal agencies and others with circular economy concepts, resources, specifications, processes, etc.? And does DOE and FEMP have experts and resources on this topic? And that might be something.
Is that a question about whether there's circular economy expertise in government agencies?
That's what it appears to me. Who is advising the federal agencies with the circular economy concepts? So are there advisors to these agencies?
So they are. I don't know who exactly they are, but I know the New York City Economic Development Corporation. They've also rolled out their own circular economy standard or principles. So they do have a team that is working on that. And I imagine so does the EPA, because a lot of these requirements for the circular economy have been written into these acts and have obviously come from professionals within the government agencies.
Well, great. Thank you, August. Okay, and just so everyone knows, this presentation, this recording, and the supporting presentation PowerPoint will be posted on our website, on our events page at within this next week. So if anyone would like to come back and listen to this recording and check out the presentation and download that, that will be available to you soon. So thank you again for attending today's webinar. August, Rabia, thank you for this enlightening presentation. It was wonderful. You can see their contact information on our on this page here. And if anyone has questions about any of this, please don't hesitate to contact me. Again, Sarah Swango. My email is swango@nibs.org. Thank you and have a great rest of your day.
Thank you so much.
Thank you very much.
Yes, and thank you all for attending.